Hello and welcome to our Chapter 7 preview. Today we're going to talk about exponent rules, and this is the shout-out edition. Alright, so I'm going to start reading a few of these. Later on in the video we'll hear some more. So this is a shout-out to Cherry, apparently my favorite student of all time. Keep up the good work. Okay, this is a shout-out. It says, "Hi, Winnie and Esteban," from Jasmine. This says, "You should put Distributive Ninja as Dr. Identity." That's a suggestion for the story. Who knows? Maybe it'll happen. We'll see more in Chapter 8. And this is a shout out that says, "Juliet, pay attention and stop reading." I bet I know who that was. And this is a shout out to Naisha for being awesome, from someone that did not write their name very clearly. So, Naisha, you're awesome. Moving on. Okay, so we're going to talk about this in class, but think about this. Would you rather have $1 million right now, or get 1 penny today and double the amount you get each day for 30 days? So what I want you to do right now is to think about this. We're going to do an activity in class. We'll actually find what is the better option and discuss, what happens with this. So think about it. You can hit pause if you'd like to think. Or I can make you pause by not saying anything for the next second. Alright, so what I'd like you to do is set up some notes. The topic is exponent rules. The essential question is, how can I make a rule finding the patterns of exponents, or searching for the patterns in exponents? That's what we're going to do today. The date I have today is the 18th of February, but you can put whatever date that you are recording this. And the notes that we're going to take are Chapter 7, but the end of this video will not be the end of your notes. So don't write summaries until I give you a slide telling you to write a summary. Okay? So take a second, set up your notes. Alright, and this is really what I was going for when I said we're going to come up with a rule based on observations we make with these patterns. So as you can see, we have exponents of 2. Well, we have, if we're going to be specific about how we say this, is if you have an exponent, for instance, to the 3rd power, which is the correct way to read this, is 2 is our base, 3 is our exponent. This means 2 gets multiplied the number of the exponent. So if I were to write this out extended, this would be 2 times 2 times 2. Okay? And just in case you're wondering, this might be a good thing to write down, because again, I need you taking notes on this. Make sure you're writing it down. So, and what we can do is, if we evaluate this 2 times 2 times 2, if we're doing the math correctly, we would get 8. Alright, so next, as you can see, the exponents here start at 3, go down 2, 1, 0, 2. That should be a 1. I'll have to fix that. That's a 1. Don't copy a 2. And these exponents go down as I go down the line. So if I were to evaluate this one, to the 2nd power is just 2 times 2, which of course equals 4. Okay. Next one, this again, remember this is 2 to the 1st power, should just be 2, and you can think of it as times 1. In fact, we can put a 1 in front of all of these, and it does not change anything because of the identity property, Dr. Identity. So 1 times 2 gives you 2. Now, this one is one that students usually solve incorrectly. And they say 2 to the 0 power, they say, well, obviously 2 times 0 is 0, but that's not what this is. I want to look at this pattern that we found. Each time here, we go from 8 to 4 to 2. Each time, we are dividing by something as we go down. And what we're dividing by is the base. So if we do 8 divided by 2, we get 4. 4 divided by 2, we get 2. So why wouldn't this pattern just continue? And we'll keep dividing by 2. So 2 divided by 2, no, is not 0. It's 1. And this is, it may not make sense, but as you can see, it follows the pattern. And also, there's another pattern we can look at here. 2 to the third is 1, 2, 3 2's. 2 to the second is 1, 2 2's. 2 to the second is 2 2's. And 2 to the 0 is 0 2's. But remember, like I said above, we can always multiply this by 1 and it's not changing anything. So that's why I can write times 1 above all the other ones. Alright, so take a second, look at the pattern, see if this makes sense to you. If you have to, hit pause. Because now what we're going to do is look at negative exponents. And negative exponents do not make negative numbers. As you will see, they follow the exact same pattern of what we were about to do. But I want you to think of it like this. Negative exponents, there's a negative in there is the opposite of a positive exponent. A positive exponent would mean we multiply whatever the exponent says that many times. So a negative exponent, we're going to do the opposite of multiplying, which would mean we divide. So still starting with our base of 1, like we have in all the other ones, and we're going to divide this by 2. And 1 divided by 2, you can do it on the calculator, you get 0.5, or you can just leave it as a fraction and say 1 divided by 2 is 1/2. So that means 2 to the negative 2 power is like dividing by 2 twice. So, or dividing by what we had before by 2, because that's how the pattern continues. And half of a half, or 1/2 divided by 2 would give us 1/4. Continue the pattern. This is 1 divided by 2, divided by 2, divided by 2, or 1/8. Alright, now I want you to hit pause and look at this pattern for a second. See if you can notice any patterns. See if you can find where there are repeats. And really I'm looking for symmetry. So take a second, pause, and I want you to think about the pattern. Okay, I'm back. I hope you paused the video, because you're supposed to. And when I said I was looking for symmetry, I want you to imagine there's this line here. And look at, on this side of the line we have 2. Below the line we have 1/2. Here we have 4. Below the line we have 1/4. Up here we have 8. Its mirror image is 1/8. Do we notice any patterns? Also, these are negative exponents. Do we notice any negative answers? It's because negative exponents do not make negative numbers. They make fractions or decimals, or you can think of it really small numbers. Positive exponents in general make really big numbers. So we can go to the next slide and you can see it looks a little neater here, but there is definitely patterns there. So if you have to evaluate a negative exponent, let's just say 2 to the negative 4th power. You would just find what 2 to the positive 4th power is. 2 times 2 times 2, which we know is 16. And then as you can see right here, because it has a negative exponent, it would have a 1 over the 16. So 2 to the negative 4th power is 1/16. Negative exponents do not make negative numbers, they make fractions. Alright, let me throw in a few shout outs here. We got a shout out to Jade, which is weird, she's not in my algebra class. And to Lauren, it's weird, but hey Lauren. And then to Zaria from Kelsey, of course my fave, with a nice little picture on there. And then a shout out to Carmel, my favorite Napoleon. So everyone wants to be my favorite in these shout outs apparently. So in general, this is what we can think about with negative exponents. Negative exponents don't make you dumber because negative exponents don't make negative numbers. Negative exponents have much action because negative exponent make, say it with me class, fractions. Okay? Negative exponents don't make negative numbers, they make fractions. Now I have a question here, what about 0? What do you think? Go back and look at this last slide or go back and rewind the video, see if you can't remember what happens when you have a number to the 0 power. Because every number except 0 to the 0 power has a certain answer. Go back if you forgot what it is, and it's not 0. Alright, your turn. I would like you to try in your notes these 3 problems. These are very similar to the problems you're going to see on the homework. So hit pause, and I'm going to work them out on my own, but you need to try this first without me. The answer to your first problem, this part right here I showed the work, would be 1 over 81. And I want you to leave it as a fraction. I'm not looking for decimals. Okay, so if you have a scientific calculator, don't tell me the decimal answer, tell me this fraction. Okay, negative times a negative gives you positive, negative times a negative gives you positive. Alright, your turn to try this second problem. Hit pause. Alright, for our second example, our final answer is y to the 5th over x squared. Now I know it looks weird, these are just variables, but since y to the 5th is positive, it stays in the numerator because you can't do anything with that to simplify it. X to the negative 2 power, remember, makes fractions, so in essence it brings it down into the denominator. Because these are not like terms, there's an x, there's a y, we cannot simplify them. This is your final answer. Okay? Now, next one, keep that in mind with the exponents, what happens to negative exponents, and we will talk about this as we work on the next problem. Okay? So, hit pause, try it on your own. If you're totally confused, I'm going to start it up in just a second. Just give yourself a chance to try it. Alright, so this big, bad, scary looking problem is actually pretty simple. Alright, so we see the 7 here. Nothing happens to the 7. It stays in our numerator. X to the 0 power, remember what we said, assuming that x is unequal to 0 would equal 1. So we have 7, and variables stacked up against numbers like this just means multiply. So we have 7 times 1. And then this y to the negative 5th power, negative exponents, make fractions, so it moves it down. This is now in your denominator right here. 2 to the negative 1 power. If you have a negative exponent that's already in your denominator, guess what? It moves up, and that's how this negative 2 moved here. Okay, so it's not negative 2. It's a positive 2 with a negative 1 exponent. It moves up to the first power is just 2. So these 3 numbers stack together, 7 times 1 times 2, we multiply those and we get 14. Now z to the 2nd power, nothing happened, it stayed in the denominator. Like I said, y to the negative 5th power moved down, and oh, by the way, when they move down or up, the exponents lose their negative sign, so y to the 5th is in our denominator. And that's the end of our video for today. Let's quick time to do a learning check. Look back at your notes. What do negative exponents do? What do negative exponents in the denominator do? Look at some of the problems that we tried. This will definitely help you with the homework. Our next video that we will be making has more shout outs, more exponents, more exponent rules, and hopefully more of these adorable little doggies. We'll see you next time.